But if the TMP goes off, that's 212 degrees and plus 180, so how is that rated for water?
Where does the temperature pressure relief pop off at? 210. 210. Or 150 pounds of pressure. Okay? And that's written right there on the top of that thing, or right on the end of those that's sticking out. It's written right there on the label. 210 degrees, 150 pounds of pressure. So you can step right up there and read it if you forget it. It's right there. This is a rating for hot water. So is that okay for temperature pressure relief? Yes, it is. Why? What's the rating for cold water? 160 psi at 73 degrees. That's the rating for cold water pipe. You'll see that on PVC. Will cold water pipe handle hot water? Yes, it will. Yes, it will. It handles it every day. You walk in there in that lavatory, turn the hot water on, and it's going to run right down into PVC pipe. And that PVC pipe is going to handle that hot water. In fact, the code says you can go all the way up to 140 degrees dumping into the drain system. So if PVC pipe under no pressure will handle all the way up here to 140 degrees, will this then work for temperature pressure relief? How much pressure is going to be on that pipe when that pops off?
It has an open end, so not much.
It's got an open end. You can't build any pressure on it. So it's going to be virtually zero because it's open-ended pipe. So if you drop the pressure here down to zero and it'll handle that, you drop this down to zero, it'll certainly go up here to 210 degrees. It'll handle it. Okay? So anything rated for hot water, any of those I mentioned, will work temperature-wise for temperature pressure relief. However, the code says that if you're going to use copper, use hard-drawn copper. Now, what's the difference in hard-drawn soft copper?
Hard can't bend.
Two.
One of them will bend easy and one of them won't. It's the only difference. One, they took, it all comes out hard-drawn, and then they heat it to a certain temperature, cool it a certain way, and it becomes soft. It's called annealing. They anneal it, and it gets softened. There's no difference in the copper. There's no difference in the pipe. There's no difference in the strength. So why would they say you can use one but not the other? If you use soft copper, you get humps and dips and traps water. It's got to go untrapped. You bend it, hand bend it, and you decrease the diameter on the inside. It's got to go full size. So it's got to go full size untrapped. Problem with PEX, you put an insert fitting, it's not full size. You reduced it down. You can't straighten this stuff out. Now you can get straight PEX, but as soon as you get that hot water in it, it's going to go all over the place. So PEX has got some problems. So you've got to really take care of PEX. You got to have to oversize it to take care of the fittings. You're going to have to really strap down some good straight PEX and really strap it down where you can't bend and move anywhere else. So PEX has some real problems. But any pipe rated for hot water will work as long as you take care of everything else. If you come over here, you said that one had backfall. Look at this one right here.
Oh, that's good.
That one's going straight up. Now that's CPVC. CPVC is okay, material-wise, because it'll handle the hot water. And it's good and straight, everything's fine there, but that's got to go downhill, not uphill. Okay? You can't trap water. Well, this one goes downhill, and it's copper, but it's reduced down to 3/8. You guys, I've seen that out there in the field a bunch.
Yeah.
Now, going back over here, that one's going through to the outside wall. Where should it terminate down there?
6 inches and those are
No more than 12. No less.
Well, the two codes are different. The international code says 1 inch above, with a 1 inch air gap at the bottom and no higher than 6 inches above grade. So 1 to 6 inches above grade. The uniform code says 6 to 24 inches above grade. But they both said 6. So if there's an answer, if that's questions on the test, the answer's got to be 6 inches above grade. Okay? You can't go anywhere else. You can't go above it, or you missed one code. You can't go below it, or you missed the other code. So the only way they can meet both codes is 6 inches above grade. But the one over here didn't go outside. It's going down into a pan. Now, guys, I'm going to just let you be on your own on this one. I'll tell you what we put on the test. I'll tell you what it said on the test when we put it on the test. But code's changed. The international code has changed. Uniform hadn't. Uniform code says don't put it to the pan, take it to the outside. The international code says you can dump it to the floor, to the pan, to the outside, or any other approved receptor. And it also says you must have a 1 inch air gap in the closet with the water heater. So there are a lot of places that say just dump it in the pan. Well, the way we looked at it when we were writing the test, and that provision wasn't all in there at that time. That, like I said, they've added to it since then, so it wasn't in there when we wrote the test. I don't know if they've changed the test or not, don't have a clue. But what we wrote when we wrote it, when we wrote the test, we looked at that and said, it still said you could dump it in the pan at that time. But what's the purpose of a pan? When do we need them?
Case of a fluke.
In case of leakage of the water heater. That's what your code book says. You only need a pan if leakage of the water heater would cause damage to the building. Then you need a pan. If leakage of the water heater would cause damage to the building. So if I dump that temperature pressure relief into that pan, we got a pan to keep it from causing damage. What's going to happen in that pan when that temperature pressure relief pops off? It's going to splatter all over the place. It's going to fill the pan and run it over because that 1 inch drain isn't going to handle it. And we're going to cause damage to the building. But the code specifically says you can't cause damage to the building. So if you dump it in the pan, you're defeating the purpose of the pan. So we should take it to the outside. And that was the answer we had at the time we wrote the test is, no, it does not dump into the pan. It needs to go to the outside. Unless that pan is sitting out in the garage where it's not going to cause any damage to anybody's building. So then you could put it in the pan. But I don't understand the international code. Because they say dump it in the pan and then they say don't cause damage to the building. So you're kind of conflicting there as far as I'm concerned. So anyway, like I said, whether it dumps in the pan or goes to the outside, read your question carefully. See what they put on there. I don't know. I can't tell you that one. I can tell you that when we wrote the test, it said no, do not dump it in the pan, take it to the outside, turn down 6 inches above grade. That's what we put on the test. And you don't reduce it down like it does there. Okay? So anyway, there's your pan. Discharging downhill, untrapped, full size to the outside or some other approved receptor. Okay? Not to the pan. This water heater is sitting on a stand 18 inches above the floor. If you're in a garage or a storeroom, any ignition source needs to be 18 inches above the floor. If you're in a garage or a storeroom where they might be storing flammable liquids or fluids. So, what is an ignition source? We ran over that yesterday. The definition there in the gas ignition source. It's a burner igniter, or an electrical switch capable of igniting vapors. Well, this water heater is an old gas water heater that does have an ignition source, no question about it. It needs to be 18 inches above the floor. Now, if you're out in the field though working, does an electric water heater have an ignition source?
Yes.
What?
Thermostat.
Thermostat? Well, it is a switch, but is it capable of igniting vapors around it? Aren't they sealed?
They're still
I
igniting.
know, I've seen a lot of burnt up water heaters.
Well, I've seen a lot of elements burn out and burn up water heaters. But that's not their normal operation. So that's not an ignition source. That's not a switch. I don't know. Now, if you're in the city of Austin says put it on that stand, don't it? 18 inches above the floor if you're in a garage or storeroom. So they call it an ignition source since they put it on a stand. I'd think it'd be kind of hard pressed to prove that it was an ignition source. And most of the thermostats are above 18 inches anyway, so it really wouldn't make any difference. So they're not going to ask you about that on test. They're not going to get into that confusion. Now, the FVIR water heaters that we have today, and just about all of them are, the flame vapor ignition resistant seal combustion water heaters,
On the floor.
they say set those on the floor. But that's got a burner. It's got a burner igniter. That's capable of igniting vapors. But they say set them on the floor. Well, the way those things work, basically, from what I understand of them, is that they have a fine mesh screen. Air can come through it. Vapors will come through it into that combustion chamber. And if they ignite, it shuts the system down and the flame cannot get back out through that screen. It's too fine mesh. It won't go back out. And it works when they're new. After you've cleaned that screen a few times because you can't get any air through it, and somebody punches a hole in it, it's no longer FVIR and it's sitting on the floor. So then you got a problem. So I don't know. Like I said, do however you want to with those. Set them on the floor if you want to. They don't ask you about that down at the plumbing board either. All they've got is that one, and it needs to be on a stand, 18 inches above the floor. Okay? You cannot install water heaters in bedrooms, bathrooms, or closed closets. Now, electric water heater in a bedroom, bathroom, I don't see, again, a big problem with that, but gas-fired, you don't want them in there.